So the first thing we're looking at, problems 1 through 6. Determine whether each of the following is inverse direct or neither. So our direct variation comes in several forms. The main general form, the main way it is written, is y equals a times x, where a is just a number. I mean, it could also be written as x is equal to a times y. We can flip those if we want. In the very we really don't like writing it, but we could have it as 1 over x is equal to a times 1 over y. We normally never see that. We're not going to look at that. But we also have it in the form of y over x equals a, or x over y equals a. These are just the main versions of direct variation. And really getting from one to the other is just manipulating the equation to get it to look like this here. Inverse variation, y equals a divided by x. We can just as easily say x is equal to a divided by y. Or if we get that a, that constant term by itself, x times y equals a. These are all different versions of direct and inverse variation. One of the biggest things to point out, we have to have two variables. We have to have an x and y. Because if we only have one variable, it's just in terms of x or just in terms of y, it doesn't matter. It's not direct or inverse. It's going to have to be neither. So x equals 3/4 is neither, because we have to have x and y. We have to have two variables. And it's also going to be neither if the variables are being added. So if we look at these here, number 1 is going to be direct. It just matches up to our version of direct. A times y is equal to x. Number 2 is inverse. Number 3. The big giveaway is the plus. How about number 4? Inverse. It's really just our y equals a over x, just flipped. Number 5. And lastly, number 6. Questions on 1 through 6. There's questions on these here. We'll go on in 7 through 9. So we look at direct inverse variation on these here. We use the two main forms. Where direct is our y over x equals a. Because if we divide the x by the y, its corresponding y for each one of these here, and we get the same value of a, then it's going to be direct. And we can check this here. We can say 16 divided by 4. Well, that's going to be 4. 11 divided by 5. We can plug that in and it tells us it's 2.2. This is not going to be direct variation because those values are not the same. I don't have to check the rest. As soon as I get one value that differs, we're done. It's not direct. Inverse is our x times y is equal to a. So we're going to multiply these numbers together. So the first we can do is 4 times 16. And 4 times 16, we'll just throw it in a calculator. It's going to tell us it's 64. 16 times 2 is 32, times 2 is 64. We get this here. Our next one's 5 times 11 is 55. Those numbers are not the same. It's out too. Both of them are gone because those are not the same number, which means this has to be neither. Doesn't work. It's not direct or inverse. Questions on this here? Number 8. Do we want to try direct or inverse first? Doesn't matter which. Direct. So this is our y over x. So we can start off with 14 over 7, which is 2. 22 divided by 11 is 2. 28 divided by 14, 2. 34 over 17, 2. 42 over 21 is 2. And 50 over 25 is 2. Since they all gave us the same value, number 8 is going to be direct variation. We don't even have to check inverse because it can only be one. It can't be both. (29) If I wanted to check direct, 29 divided by 2 is 14.5. We can do 14.5 divided by 4, 3.625. That does not work because those are not the same amount. We can move on and try inverse. Well, 2 times 29 is 58. Four times 14.5 is 58. 8 times 7.25 is 58. And then lastly, 16 times 3.625 is actually going to be 58. So we know this one is going to be inverse. Questions on 1 through 9? All right, let's look at number 10. So when we look at any of these here, especially with simplifying, the first thing we want to do, the main thing we want to do is simplify the top and bottom of the fraction as far as possible, and then simplify from there. So when we look at the top of this here, 2x squared is already as simplified as it gets. We can't simplify it any further. The denominator, 3x squared minus 4x. So we do have an x squared term. There is some factoring that might occur. But before we do any of our parentheses, we do want to check and make sure there's not a greatest common factor amongst these two terms. Is there one? Yes, and it is. All right. Now, if we factor the x out of 3x squared, we get 3x. If we factor the x out of 4x, we get 4. And after doing that, we do have an x in common on top and bottom. The x on bottom that I just highlighted, since it's being multiplied by the 3x minus 4, it means we can simplify it out of the top and bottom. So the x on bottom is actually going to factor out completely. The 2x squared on top is going to become 2x. Questions on this here? Questions on any of this so far? All right. Questions on 32? We feel good with 32? Kind of, sort of. What would we do first on top? We factor out 2. It would turn 32 into 16. We still have the x squared minus 25. Is there a greatest common factor on bottom? No, but we can factor it. Some would probably rewrite it back out as 4x squared minus 17x plus 15. But since we can't factor out a greatest common factor, there's no reason to just go on and factor it. Since the third term is positive, the signs are the same and match the sign of the middle term. So we'd have negative and negative. Factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. Factors of 15, 1 and 15 or 3 and 5. Where do we want to go first? Three and 5. If we check this here, 2 times negative 5 is negative 10x. Negative 3 times 2x is negative 6x, giving us negative 16x. If we switch the 3 and 5, we'll get the exact same thing. So do we want to switch the 3 and 5 or 1 and 15? Or do we want to switch the 3 and 5 to 1 and 15 or switch the 2 and 2 to 1 and 4? 1 and 4? Where do you want the 4? With the 3 or the 5? Okay. We'll put it with the 5 and check it again. X times negative 5 is negative 5x. Negative 3 times 4x, negative 3 times 4 would be negative 12. Negative 5x minus 12x would indeed give us the negative 17x we wanted. So these are the correct factors. Now, at this point here, nothing simplifies on top and bottom, but the denominator is simplified as far as possible. However, the numerator can be factored a little further because of our x squared minus 25, or 16x squared minus 25 does look like it might be a difference of perfect squares. Because 16x squared, well, the x and x, and what times itself is 16? 4 and 4. What times itself is 25? 5 and 5. So now the numerator is factored as far as possible. Both of our expressions, or all three expressions on top. The 2 for sure, and the 4x plus 5, 4x minus 5, no greatest common factor in either set of parentheses. Degree is 1. They're simplified as we get. And incidentally, we do have a common term on top and bottom that will reduce, leaving us with 2 times 4x plus 5 over x minus 3. And that is it. Questions on this here? We good? We'll skip over 12 because cubics aren't going to show up on the test. So we'll look at 13 instead. Do we want to factor the top or bottom first? We can factor the bottom because the bottom is going to factor a little bit nicer than the top, because x squared minus 4 is a difference of perfect squares. So it's going to factor to x plus 2 times x minus 2. That's just how difference of perfect squares factors. And the nice thing about factoring that first is it gives us a hint at what the numerator might be. Because if we get x plus 2 or x minus 2, we will have something in common on top and bottom, and it will reduce. Numerator does not have a greatest common factor amongst those three terms. But since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which one do we want? 2 and 6. Now, because we do want the 2, but it doesn't really give us a hint really at what's going to be plus or minus. Do we want the 2 positive or negative? Positive. So we'll plug it in there and then check and make sure. X times negative 6 is negative 6x. 2 times x is plus 2x, giving us negative 4x, which is indeed the middle term that we wanted. And since we have it set up this way, and we do have it factored correctly, we actually have an x plus 2 in common on top and bottom, leaving us with x minus 6 over x minus 2. Questions on this here? You ready for the next one? We're going to look at multiplication next. When we have these monomials, these monomial expressions where we don't have any addition, subtraction on top and bottom, there's no factoring we have to do. It might be nice to just go on and multiply the numerators with the numerators, denominators with denominators. On top, the only like term with 4, the only number we're going to multiply with 4 is just 4. There's no other numbers there to multiply, so it's just going to be 4. I'm going to look at x next. Well, it's the only x that shows up on either numerator, on either top of the fraction. However, we do have y cubed times y. Whenever we multiply like bases, we add the exponents. So 3 plus 1 is 4. And we have y to the 4th. And also, we're finished multiplying the numerator, so the total, or the whole numerator, is 4xy to the 4th. Denominators. Well, the only number we have on bottom is 8. However, we have x squared times x. And x squared times x is going to be x to the 3rd. And then we just have y. Telling us that we have 4xy to the 4th over 8x cubed y. Now at this point here, we'll start simplifying. Now our 8 over 4, well, we just plug that in a calculator. 8 over 4 is 1/2. So I know for sure I have a 2 on bottom. If I wanted to, I could write the 1 on top. But really, there's no point in writing that, especially if we have terms left on top. Now, if it turns out that we have x and y on bottom, there's nothing left on top, then I'll need to go back and put that 1 back in. Well, let's look at our other variables first. Our next one, x over x cubed. When we divide like bases, we subtract the exponents. So 3 minus 1 is 2. And since it's bigger on bottom, it's going to stay on bottom. And lastly, y. Y to the 4th over y. 4 minus 1 is 3. And since it's bigger on top, it's going to stay on top. And since we do have an expression, we have something on top of the fraction, we don't necessarily need that 1. So I don't have to write it as 1 times, I can be quiet, 1 times y cubed. It's just y cubed. And that's it for 14, or any of them like that. 15, on the other hand, we already have it set up as multiplication, which is fine. But before I actually start multiplying or simplifying any things, it might be helpful to factor everything out. We want to factor it down and then go from there. So, x minus 1 and 2x are factored as far as possible. There's nothing else we can do about those. Simplified as they get. X squared minus 4x has the greatest common factor of x. And if we factor that x out, x squared becomes x, 4x becomes 4, telling us we have x times x minus 4. Now after doing that, it does decrease the degree to 1, So actually that is simplified as it gets. Nothing else that we can take out of both terms. X squared plus 3x minus 4. There is no greatest common factor between those three terms. So nothing to factor out there. So we'll do our two sets of parentheses with three spaces. Since the third term is negative, our signs are opposite, plus and minus. Factors of the first and third term, so factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. I wouldn't pick 2 and 2, well, for two main reasons. One, if we have x plus 2 times x minus 2, that's the setup or factorization of difference of perfect squares. Not going to work. Also, I have an x minus 1 on bottom. So if I get an x minus 1 on top, because we don't have one yet, that would simplify out. So there's a good chance x plus 4 times x minus 1 is the factors we want. X times negative 1 is negative x. Four times x is plus 4x. Negative x plus 4x, negative 1 plus 4 is indeed positive 3x. Those are the factors that we wanted. Now that it's factored, in factored form, we can multiply together. When I write it out, I like to get my monomial terms out front just so that it's easier to keep everything straight and organized nicely. Now at this point here, the x minus 1 and x minus 1 on top and bottom will cancel because we do have products on top, products on bottom. They simplify. Same reasoning, the x over x will simplify. Telling us that we're left with x minus 4 times x plus 4 all over 2. Questions on this here? Questions on anything we've done so far? You ready for the next one? Doesn't matter where we start. I'm going to start with 2x squared plus 4x because there's a greatest common factor of 2x. I'd start with wherever we see greatest common factors because that's going to make things a little bit nicer. Do you want to factor the other numerator or go down to the denominators first? Let's do the other numerator then. No greatest common factor. So we can go on to our two sets of parentheses with three spaces. Since the third term is negative, the signs are opposite. Factors of x squared are x and x. Now we would go to our factors of 4, which is 1 and 4 or 2 and 2. Or I can look right back at number 15. It has x squared plus 3x minus 4. It's going to tell me that this is 4 and we're just using the steps we already used before. X squared plus 4x plus 4. No greatest common factor to pull out, so we'll go straight to two sets of parentheses with three spaces. Since the third term is positive, our signs are the same and match the sign of the middle term, so plus and plus. Factors of x squared are x and x. 1 and 4 or 2 and 2? 2 and 2. I will tell you that is the correct factorization because we get 2x plus 2x, which is indeed positive 4x. And that brings us to our last one, x squared minus 4x plus 3. Since the third term is positive, the signs are the same and match the sign of the middle term, so negative and negative. Only factors for x squared are x and x. And the only factors of 3 that we have are 1 and 3. Now we can multiply everything together, and for the most part, it's just all we're doing is putting the parentheses next to each other, showing that they are being multiplied. On top and bottom, we have an x plus 2. Now, realistically, whichever one on bottom I actually cross out really does not make a difference, because I can go here and here, or the other way I had it. We just have one of the x plus 2's on top and bottom simplifying out. We also have an x minus 1 on top and bottom simplifying out. And that is actually it. And that is our final answer. Questions on 16? (17) X squared minus x minus 12 over x squared minus 16 times x squared plus 2x minus 8. One thing that's kind of nice to notice is that none of the denominators or numerators have a greatest common factor to pull out. So we don't have to do that first and then rewrite it in factored form. X squared minus 16 would factor 2. X plus 4 and x minus 4, because it is indeed a difference of perfect squares. We can go to x squared minus x minus 12. Since the third term is negative, the signs are opposite. Only factors of x squared are x and x. 1 and 12, 2 and 6, 3 and 4. Well, which one are we hoping for? 3 and 4. Yep. Well, one thing we know for sure at this point, those two are gone. And it's even though I haven't multiplied yet, I have two expressions being multiplied on top over two expressions on bottom. X minus 4 over x minus 4 is already there. We can actually simplify at this point. We don't have to multiply because they're already over the top of each other. But it also helps us when we come over to our last expression and we see that the 8 is negative, so the signs are opposite. X squared is x and x. 8 is 1 and 8, or 2 and 4. The only other term I have left on bottom is x plus 4, so it might be nice if it's x plus 4 times x minus 2, which it is. And I have a feeling at this point you went, and we know that those are gone, telling us that it's x plus 3 times x minus 2. And that's as far as I would go. I would not rewrite this or write this out as x squared plus x minus 6. There's no reason to multiply it. X plus 3 times x minus 2 is the final answer, the simplified form. Questions on this here? With dividing expressions, before we factor or do anything else, the first thing I'd do is just get it back to multiplication. Keep, change, flip. Keep the first one the same, change it from division to multiplication, and flip the second. Now, since it is monomials, we can go on and start multiplying. I'm going to multiply the denominators first, because y to the 8th times y to the 7th would be y to the 15th. On top, x to the 3rd times x to the 4th is x to the 7th. And then we just have y. Now, it seems odd I've just skipped over 32 times 8. Well, 32 times 8 is 256. It also really didn't matter when I did the multiplication of those, because multiplication order doesn't matter. (256x to the 7th on top ain't going to reduce with anything, because there's nothing in common with it on bottom. Y over y to the 15th. Remove 1 from the top and bottom. The top is gone. The bottom becomes 14. Questions on this here? Depending on how well you can keep your terms straight, I wouldn't, unless you can keep them all really straight and keep everything together, you can do this. If not, I wouldn't. Because what I'm saying and what I'm kind of hinting at is, well, we can set it up this way, and I can look at the numerator and say, since 40 is negative, our signs are opposite. X squared is x and x. Factors of 40 are 1 and 40. 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, we're done there. It's going to be 5 and 8. X squared plus 8x minus 20, well, we'd have opposite signs. X and x, 20 is 1 and 20, 2 and 10, 4 and 5, 1 and 1, positive 10 and negative 2, which really isn't any different than what we would normally do because nothing's changing. But here's where it gets a little stretchy, because on top I'm going to have 2 sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term, so plus and plus. Factors of the first term is going to be x and x. Now, our factors of the third term, we're not looking at 40, because I've already switched it from division to multiplication, so we're looking at the factors of 20. So what we've done is we're factoring, flipping, and changing all at once. We're doing 3 separate things all together. And if we can keep track of all that, we're good. If not, rewrite it, then factor it. Then we would do a similar thing on bottom. You get our 8 and 5. Because if we're able to keep track of all this, great. If not, what I would suggest is then do this. Keep the first one the same, change it from division to multiplication, and flip that second expression, then factor. Then multiply and simplify. There we are. Telling us that our final answer is x minus 8 over x plus 2 over x minus 2 times x plus 8. Questions on this here? We'll pick this up on Monday, along with